Caroline, Adi, Sophie, and Veronica found a suitcase containing $300. Caroline thinks they should invest their $300 and buy as many lottery tickets as possible. If they win, they will split the $12 million. 49 balls numbered 1 to 49 are being tumbled in a rotating barrel. 6 balls are drawn one after the other without replacing them. A winning lottery number has the same numbers as the ones drawn, in any order. Each ticket costs $3. Let's look at the number of outcomes. First of all, they are being drawn one after the other, and they're not being put back. Okay, so they're just being drawn out of the barrel. This is without replacement, and the order doesn't matter. Since the order doesn't matter, it's a combination. So we're talking about a combination without replacement. Okay, so it's n factorial over n minus r factorial over r factorial. And the n is the number of balls, 49 balls. The r, the restriction, is you're restricted to 6 balls. So we're going to have 49 factorial over 49 take away 6, which is 43 factorial, over r factorial, which is 6 factorial. All right, handy dandy calculator. 49 factorial. Which, it's some number times 10 to the power of 62, so it's huge, divided by 43 factorial. And then divide all that by, so that's still a huge number, by 6 factorial. Which brings it down to the realm of like very close to 14 million. That's 13,983,816. Okay, that's 0.99999. We'll make that 16. Like that. All right, so that's a lot of outcomes. And we want to know the probability of winning. Well, if you're talking about one ticket, that's one outcome out of the 13,983,816 possible numbers, right? So it's one number out of those possible outcomes. And they're gonna if they're gonna take their $300 and each ticket costs $3, they're gonna buy 100 tickets. So the probability of winning is they're going to have 100 different outcomes out of the 13,983,816. All right, by the way, the probability is 0.0000007151123, and it goes on forever. That is not a good probability. Now, as a percent, it's only marginally better. It's 0.00007151123. If we're talking about 100 different tickets, then that's going to be 100 out of the 13,983,816, which, gives us, well, this number again, but not a percent. Okay, so 0.0000715. And as a percent, take away 2 zeros. So you have 0.000715. Okay, it's like 7/10,000ths of a percent. So that's not really winning conditions here. All right. Now what's the expectation? So expectation is the probability of winning times what you would win. In this case, it would be 12 million. Take away the probability of losing times what you would lose. In this case, the 300. So its probability of winning is this 0.0000007151122, and it goes on times 12 million. Take away the probability of losing, which now to get the probability of losing, we're going to do 1 take away this number, right? So it gives us, so 1 take away 0.000000715, and that gives us 0.999999992848876. Anyway, times the $300 that you would lose. That gives you $85.81. Take away pretty much $300. So I guess $299.99785. It goes on for a while. That's going to give you a negative expectation. So you'd expect to lose $214.18. If you were betting $300 like 100 times on average, this is what you would expect. You expect to lose pretty much all the time. You might, win a little, once in a while, but overall, you're losing. So the expectation is negative. It means it's unfair in the lottery's favor, not in your favor. A D thinks that they should put all of the money on red 25 on a roulette wheel. A roulette wheel has 38 equally likely numbers that a ball lands on when the wheel is spun. The roulette wheel pays out according to the odds. The probability of winning. You have one outcome. That's red 25 out of 38 possible outcomes. It's 1 out of 38. When you think about it compared to the lottery, that's pretty good. It's still terrible. It's 0.026316, which is only 2.63%. You're not going to win, but you could, right? With the lottery, you're not going to win, but you're not going to win. With this, I guess you could win. You're not likely to. You have a 2% chance, almost a 3% chance of winning. The odds of winning. Now, in this case, it pays off according to the odds, so we have to calculate the odds. It's the number of ways of winning out of the number of ways of losing. There are 38 ways in all, so that means there are 37 ways of losing. One way of winning out of 37 ways of losing. I want to calculate how much I would win. 1 to 37 is equal to the 300 that we bet out of how much we would expect to win. The amount that we would win would be in proportion to the 1 to 37. Cross multiply, I'm going to switch the x and the 1. I'm going to multiply the 37 times the 300. That gives us 11,100 if we win. Then we need to figure out the expectation. The expectation is the probability of winning times our winnings, take away the probability of losing times our losings, like what we would bet. Probability of our winning is 0.026316. This is it as a full decimal, as far as the calculator would allow me, times the 11,100. Take away the probability of losing. The probability of losing is the opposite of winning, so it's 1 take away this number, which gives us negative 0.9736842. It goes on forever. Times what we bet, the $300. We work that out. That gives us 292.105. Take away 292.105, which is 0. When you are betting the odds, the expectation is always going to be 0. It's a fair game in nobody's favor. It's a totally fair game. Veronica would like to play a game where 3 dice are rolled, 3 coins are rolled, and a spinner with the colors red, green, blue, yellow, purple are spun. She will bet all of the money, that's $300. Veronica will win if the die all have the number 6, and each coin comes up heads, and the color purple is spun on the spinner, as shown here. This game also pays out according to the odds, the probability of winning. We have to look at all the number of outcomes. So the outcomes are going to be 6 times 6. Like there's 6 possible numbers you can get on the die. Not that this is showing a number 6, it is, but that's not the reason it's 6. It's because there are 6 possible answers, possible values for the first die. For the second die, there's 6. For the third die, there's 6. For the first coin, there's 2. So it's going to be 6 times 6 times 6 times 2 times 2 times 2. Times, well, there's 5 outcomes, times 5. 6 times 6 times 6 times 2 times 2 times 2 times 5, which gives us 8,640. So the probability of winning is 1 out of 8,640, which is 0.000111574, or 0.011574%, which is better than winning the lottery, but not nearly as good as the roulette wheel. My recommendation would be roulette wheel. The odds of winning, because we need to calculate what the winnings would be, is the number of ways of winning out of the number of ways of losing. Okay, if the total number of outcomes is 8,640, only one of them is a winner. That means that 8,639 are losers. The number of ways of winning, 1 out of the number of ways of losing, 8,639. Them's not great odds. Anyway, that gives you a decimal. We're not going to look at that. I want to use the odds to calculate how much we would win. Let's look at a ratio. 1 to 8,639 is equal to what you bet out of what you win. What you're going to win should be bigger. So it's smaller over bigger, smaller over bigger. I want to get the x alone, so I'm going to switch the x and the 1. The 8,639 is going to come up and multiply 300. X is equal to 300 times 8,639. That will give us $2,591,700. The expectation, because we're betting the odds, you can just say the expectation is going to be 0. But let's look at it. It's the probability of winning times the winnings, take away the probability of losing times the losing. The probability of winning is 0.000111574 times the winnings, the $2,591,700. Take away the probability of losing. 1 take away this number gives us 0.999888426 times how much you would lose, how much you're betting. So times the 300. That gives us 299.965. Take away 299.965, which is 0. We expect to win nothing, which means it's a totally fair game. It's a totally fair game, but the probability of winning is quite low. Let's compare as we dare For each game, determine how much a player would win if they won, the probability of winning, the odds of winning, and the expectation. What game do you think the student should play and why? For Caroline's game, let's recap. The probability of winning is 1 out of 13,983,816, which gives us this really nasty decimal. The odds of winning is 1 out of 1 less than that, out of 13,983,815, which gives us this nasty decimal. The expectation is negative $214.18. This is a totally unfair game in the lottery's favor. So we're not playing Caroline's game. For a D's game, the probability for winning. For a D's game, the probability of winning is 1 out of 38, which is 0.0263, which is 0.0263 or 2.63%, which is a percentage greater than 1, which is much higher than this stuff over here. Anyway, the odds of winning is 1 out of 37, which gives us 0.027027 repeating. The expectation was 0 for Veronica's game. The probability of winning was 1 out of 8,640, which gave us 0.00011574. The odds of winning is 1 out of 8,639, which gives us 0.00011575. The expectation was also 0. These two games were fair. It's just a D's game has a higher probability, lousy probability, but still much higher than Veronica's game. Both of them have the probability of winning that's drastically higher than Caroline's lottery game, which is really the 649. The moral of the story is play the roulette wheel. Red 25 is your number. No, the moral of the story is invest your money into day trading. Invest in the stock market. You're not going to lose money. There you go. Okay, all these other gambling things, they're losing money all the time. These people are going to lose. All right? Even a D's, she only has like a 2% chance of winning. Veronica has 0.01% chance of winning. And in Caroline's game, she has a what is that? 0.00007% chance of winning. I mean, these are not great odds. But a D's game has the best odds of all. She has a 1 chance in 37. The odds of her winning is 1 in 37. And compare that to the other odds. So a D's game is the game they should play if they have to play one of these games. Otherwise, invest in the stock market. Have a good day.